In this lesson, we will talk about the concept of something called a vector. A vector is something that has direction and it has a magnitude or a value, an amount in that direction. We often represent vectors by arrows, where the length of the arrow represents the magnitude and the direction of the arrow represents the direction. The arrow itself is not the vector any more than this is a coffee cup. This is a drawing or a representation of a coffee cup. It's not a coffee cup. Likewise, this is not a vector. It represents a vector of this magnitude and this direction. Let's start with the coordinate system. We'll let y be up and x be in this direction. Now we could create a vector that goes along the x-axis like this. For instance, that vector might represent the fact that we have a box here and we have moved it 5 meters along the x direction. What would we do if we wanted to move it 7 meters along the y direction in this direction? Well, then we would represent that by a vector which is 7 meters. Well, if this represents 5 meters, then this one needs to be a little bit longer to represent 7 meters. Let's say we have a vector in this direction. We draw the x-axis here and here. And let's give it a magnitude of 10. It could be 10 newtons, it could be 10 meters per second squared, it could be a velocity of 10 meters per second, it could be a number of things, but whatever the units are, let's say it's 10 in value. Then we look at its projection. We have this angle theta along the x-axis. And the value of this then would be 10 times the cosine of theta. We look at its projection along the y-axis here, which could be drawn over here if you complete the parallelogram. And this would be 10 times the sine of theta. So when we write this, we actually would write this vector f, which has a magnitude of 10, and say that the vector f is equal to 10 cosine theta in the x direction plus 10 sine theta in the y direction. And in this case, we see the x direction is negative, so we would have to say that this is a minus 10 times the cosine of that angle in the x direction, and a plus 10 times the sine of theta in the y direction. If this is our vector f, this is the x component, which we will call f sub x. This is the y component, which we will call f sub y. And we would say that the magnitude of f, mathematically written to look like an absolute value of the vector, but usually we would just write an f like this, is going to be the square root of fx squared plus fy squared. Looking carefully at this, that's just the Pythagorean theorem. If that were c and this were a and b, we would have c squared is equal to a squared plus b squared. C is equal to the square root of a squared plus b squared. And that's all we have down here. If we want to find the angle theta, we would say the tangent of theta is the opposite, Fy, over the adjacent, Fx. Take the inverse of both sides, and we get the actual angle then is the arctangent of the y component over the x component.